Hello dear student, welcome to DHU Labs. Today in this video, we will discuss MCQ practice series of controller part number 13. Before starting this video, if you not subscribed our channel DHU Labs, I request you please subscribe it. I also request please like and share it. For more information, you can also visit our website dhulabs.in. Question number 1. The figure shown below represent which controller output waveforms? Option A, D controller, that is a derivative with direct action. Option B, I controller with direct action. Option C, I controller with reverse action. Option D, D controller with reverse action. See, I indicate integral controller and D indicate derivative controller. The answer is option number C, that is a I controller, that is an integral controller with reverse action. See, as shown in the figure, the bottom plot is represent the percentage of the error with respect to time, and top portion is represent the controller output with respect to time. So initially, when the error is a 0, the output is a constant. When step change is applied, let us consider it is a one step change. The output, that is a P output, is changed like T. Okay, with respect to time, it will be changed. But see here, it will be changed in the decreasing side. Okay, so we know that the integration of the 1 is nothing but it is a T. So in this case, when you apply the step change, you receive here RAM signal, but RAM signal you receive in the decreasing side. Okay, so it is a called reverse action. So here the output is integral controller output with reverse action. So answer is option number C. Question number 2. The figure shown below represent which controller output? Option A, derivative with direct action. Option B, integral with direct action. Option C, integral with reverse action. Option D, derivative with reverse action. The answer is option number B, that is an integral controller with direct action. See, as shown in the figure, the down part is represent error signal in percentage with respect to time. Similar to the top portion of the waveform is represent controller output, that is a P out in percentage with respect to time. Initially, the error is 0, so then the controller output is a constant. After when the step changes occurs, that is, let us consider 1 degree step changes occurs, okay, or 1 amplitude step changes occur, or 1%. At that time, the controller output is shifted like RAM signal, and it will go continuously increase with respect to time. So it look like has a positive ramp. We know that the integration of the 1 is a T. So in this case, the waveform represent it is the output of the integral controller with direct action. Question number 3. The figure shown below represent which controller output? Option A, derivative controller with direct action. Option B, integral controller with direct action. Option C, integral controller with reverse action. Option D, derivative controller with reverse action. The answer is option number A, that is a derivative control with direct action. See, as shown in the figure, the first portion of the plot waveform is represent error signal in percentage with respect to time. Similar to the output signal is a bottom plot is represent percentage of the output of the controller with respect to time. So see, in this case, the error signal is continuously increased with respect to time. So it's look like the T, that is a ramp signal. Similar to the output is a continuously constant signal, that is we can say it look like step. So we know that the T is my error and here output is a 1. So when you apply the derivative of the T, you receive here constant value, that is a 1. So here the output is nothing but it is what this waveform is indicate derivative control direct action output. And here we are taking the derivative with respect to time. Question number 4. The figure shown below represent which controller output? Option A, derivative with direct action. Option B, integral with direct action. Option C, integral with reverse action. Option D, derivative with reverse action. The answer is option number D, that is a derivative with reverse action. As shown in the figure, the top portion is represent error signal with respect to percentage and bottom portion is represent controller output in percentage and both are represented with respect to time. See, error signal is continuously decreased with respect to time, so it looks like the reverse ramp. And here the output is a constantly constant. Okay, so we know that when we apply the derivative of the t, you receive the signal is a 1. Okay, so this waveform is look like as a derivative control, but here the representation is it is a reverse because error is a continuously decrease, so we can say it is a reverse action. So here the output is option number D, that is a derivative control with reverse action. Question number 5. The figure shown below represent which controller? Option A, proportional. Option B, integral. Option C, derivative. Option D, PI, that is a proportional and integral. The output is option number A, that is a proportional. See, as shown in the figure, there is an operational amplifier is used. And here in this case, the VEs represent error signal with voltage error signal. So this VE signal is applied to the inverting terminal, that is a negative terminal of the operational amplifier through resistor R1. This R1 is indicate input resistor. And there is a feedback element is present, and this feedback element is nothing but it is a RF. Okay, and here the positive terminal of the operational amplifier is connected to the ground. So this operational amplifier is look like inverting type operational amplifier. So when we solve this equation of the operational amplifier, the V output is equal to minus RF upon R1 into VE. This minus sign is due to the inverting terminal sign. Okay, because we are connected this RF and R1 and VE to the inverting terminal. So when you solve this equation, you receive V output is equal to minus RF upon R1 into VE. And we know that this RF upon R1 both are the constant term. So we can put their proportionality constant, that is a Kp. So here the output equation is look like V out is equal to minus Kp into VE. And here negative sign, so it is work like as a reverse proportional control. So here the output is a option number A, proportional controller output. Question number 6. The figure shown below represent blank controller. Option A, proportional. Option B, integral. Option C, derivative. Option D, PI. The answer is option number C, that is a derivative. See, as shown in the figure, there is an operational amplifier is used. And here we can apply VE signal, that is an error in form of the voltage, to the inverting terminal of the amplifier through the capacitor C. And there is a feedback resistor RF is connected here for the positive terminal of the operation amplifier, which is connected to the ground. So this operational amplifier is look like the inverting case. Okay, when you solve this equation, you receive the output equal to minus RF into C into dVE upon dt. So see here, the derivative term indicate what? It is a derivative controller output, and here minus sign due to the inverting. So here the output, this operational amplifier is represent like what? Derivative controller with reverse action. So here the output is option number C, that is a derivative. Question number 7. The figure shown below represent blank controller. Option A, proportional. Option B, integral. Option C, derivative. Option D, PI. That is a proportional integral. The answer is option number B, that is a integral. See, as shown in the figure, that is a error voltage supply VE is connected to the inverting terminal through the resistor R1. The feedback element is a capacitor. Positive terminal of the op amp, it is connected to the ground. So when you solve this equation, V out, you receive minus 1 upon R1 into C integration VE into dt. This integration sign indicate it is a integral controller, but here this is a minus sign, so we can say it is this op amp is look like integral controller with reverse action. So here answer is a B. Question number 8. The figure shown below represent blank controller. Option A, PI, that is a proportional integral. Option B, PID, that is a proportional integral and derivative. Option C, PD, that is a proportional derivative. Option D, proportional. The answer is option number B, that is a proportional integral derivative controller. See, as shown in the figure, there are the total 5 operational amplifiers used. Among them, first amplifier, it is a RC circuit is there, so it's look like integral controller. The second amplifier, that is a CR circuit is that, so it's look like the derivative. And third one, that is a R1 RF, that is a two resisting elements are present, so it's look like proportional. Then fourth amplifier, it is used for the summing application. Okay, so it is a summation. And the fifth one, it is used for the inverting case. Okay, with gain 1. So here when you solve this equation, the V output have three terms. First term is a proportional term, second term is an integral term, and third one is a derivative term. So here the combination of the three controller output is coming in the picture. So this operational amplifier figure is represent PID controller. So here answer is option number B, that is a PID. Question number 9. The figure shown below represent blank controller. Option A, PI, that is a proportional integral. Option B, PID, that is a proportional integral derivative. Option C, PD, that is a proportional and derivative. Option D, proportional. The answer is option number A, that is a proportional integral, that is a PI. See, as shown in the figure, so we can apply here the VE signal to the inverting terminal through the resistor R1. And the feedback point of that is a R2 and capacitors are available and they are connected in series. So when you solve this equation, you receive V output is equal to in term of the proportional and integral term. And here the positive terminal is connected to the ground. Okay, so see here this figure is represent proportional integral controller output. Question number 10. The figure shown below represent blank controller. Option A, PI, that is a proportional integral. Option B, PID, that is a proportional integral derivative. Option C, PD, that is a proportional derivative. Option D, proportional. See, as shown in the figure, only one operational amplifier is used. And here we apply VE, that is a error in form of the voltage, to the first one is a R1C1 parallel circuit. And in a feedback point of view, there is a R2C2 capacitors are connected in series. Okay, so when you solve this equation, you receive the output in three forms. So here that three form is nothing but is a proportional, integral and derivative. This figure is look like as a PID controller output. Compared to question number 8, in that case we use total 5 operational amplifier to design PID controller. So it is a possible to design PID controller by help of the only one operational amplifier we already shown in this case. Okay, so there are a lot of possibility. If you want to design PID controller by using one op amp, then it is a possible. If you want to design PID controller more than one controller, then it is also possible. So hope you receive very good information from this video. Please like, share and subscribe our channel The Edulabs. Thank you very much for watching.